So for this one, this is our free response part. So cost of standard vet services at a local animal hospital. Isn't it funny how I talk so much about a vet? Follow a normal model with a mean of 80 and a standard deviation of 20. So 80, up 20, up 20, up 20, down 20, down 20, down 20. So click draw and clearly label this model. Make sure you show all the percents. So this is 34, this is 34, which together make 68. This is 13.5, this is 13.5, which together makes 98. I'm sorry, 95. My mistake, so sue me. That's 95. This is 2.35. This is 2.35, which the grand total from here across to here makes 99.7%. And so that means that these back here are both 0.15 and 0.15 for my total of 100. It said all the percents. A lot of you didn't put that as 68, 95, 99.7. Some of you didn't put the numbers across. Okay. So this is cost of vet services for a title. Okay. Is it unusual to have a vet bill of $125? Well, 125 is here, which it turns out is some of you found out to be 2.25 z-scores. And then for some bizarre reason, you said something about 3 standard deviations. I've never talked about that. We've discussed multiple times anything outside of 2 standard deviations. That answer is yes, because it is greater than 2 standard deviations. Above the mean. I thought that was an easy question, but for you 15 who copied that answer offline, aren't you dumb? So it does have a z-score if you wanted to find it. Let's see, 125 minus 80, the raw score minus the mean divided by the standard deviation, which makes 45 over 20, which equals 2.25. Sure, doesn't show me anything, but 2.25 is unusual because it is greater than 2 standard deviations above the mean. Okay, what is the IQR for this veterinary services? All right, here we go. So I told you that the first quartile is a negative 0.67. We've discussed this. So Q1 is 0.67 and that Q3 is positive 0.67. And I said, you'll be able to do this. You'll need to know this. Write this down. You're not paying attention to me. But then those of you who copied this also copied this offline somewhere. Oh, aren't you the intelligent ones? And oh, didn't you get a 0 for that section also? So where this was 20 points, these were both worth 5 points each. So there was automatic 0 out of 10 you got on that. Dropped your grade rather quickly. So to find this, I'm going to go second distribution and do a normal CDF. And I'm going to go from that to a negative 0.6. Oh, no. I'm sorry. I'm at the wrong place. I want to go second distribution inverse norm. Whoops. Whoa. Back. I want to do inverse norm of 25%. Whoops. Let's go 0.25 of these numbers. All right. And paste that. Enter. And that tells me the negative 0.67. I've already told you that. So we want to go 0.25 for 80 and 20. And that number is going to be $66.51. This is money. So then Q3, I do the same thing on. I do second distribution 3, go 0.75 of those numbers. And that number is $93.49. See those numbers? 93.49. And then I subtract those two. I say, and I needed to see this, 93.49 minus 66.51. It's $26.98. Okay, $26.98. That's my IQR. Ladies, guys, you need to remember these numbers. Q3 is positive 0.67. Q1, first quartile, is a negative 0.67. In other words, from the mean, 2/3 of a standard deviation either way is my second and third quartile. All right, let's look at the back page now. All right, where to compare the two distributions of the women's height. This is the US women. This is the European women. They're both in centimeters. Okay, they're both in centimeters. And so what we look at, whoops, sorry, let's adjust that just a little bit. So we're going to cuss at this. So it looks like the approximate middle of this, they're both roughly symmetric. I would say that they're both unimodal. So I'm going to say both histograms are roughly symmetric and unimodal. And this is where some of you came up with a term, asymmetric. Obviously, you looked up that answer online, so I just docked you that full 10 points for that section. Dadgum it all. I think maybe some of you said this one was asymmetric. I don't know why, but I wouldn't say that. Plus, you can't tell. My numbers over here, which we're going to answer down here on B, are not the same, so we're not worried about that. Both histograms are roughly symmetric and unimodal. The center of the heights of US women is about 164 centimeters, which is greater than the European women, oops, I'm supposed to, oops, boy, bad job of abbreviating there, Pruitt. It should be heights of European women, which seems to be between let's see, this is 150, 152, 154, 156, 158. So this looks to be between, if this is 160, this is 161, and this is 163, which we can say it's 162, which is about 162 centimeters. Context, height, center of the heights, European women, US women, 162, 164, greater, comparing. Compare the distributions. Okay, so we've talked about the center, I've talked about the shape. Both have gaps the US women at around 100. So they're going by fours here. So this is 2, 172, 174, 176, 178. The US around 178 centimeters, and the European around 180 centimeters. So that might be unusual. There's a gap there. Let's see. We've talked center, unusual, shape, now spread. Okay, the spread, this is 152. So that means this is 151, this is 153, 154, 150. Excuse me. So this is 152, 151, 150. And so that makes this 149. So let's see, 172, 173, 174, 175, 176. So we'll say about, we go from 180 to 150, that's 30 centimeters. Okay, but this doesn't have 150. So we can say, yeah, that's 150, 149. So we can say the US women had a spread of about 30 centimeters, where this one has a spread, no, this is 178, sorry, about 28 centimeters, which is smaller than the spread of 100. Yep. So the US women have a range of about 28 centimeters, which is smaller than the European spread of about 30 centimeters. Okay, so center, unusual, shape, and spread. Don't always have to follow that. And I use context. The heights of the US women, the heights of the European women. You have to talk about what it's talking about. Okay, it says now at the bottom, while the scales histograms are the same, scales going across, there is something that could be improved so that we can compare these two distributions better. Identify this improvement and explain why it would be better. And that reason is right here. This goes up by increments of 5. This goes up by increments of 2. So there's a lot more taller women here. I mean, that goes up, that looks to be 18 or 19. Where on the US, the tallest women of 164, only goes up to 15. Okay, this has more spread. This is more closely knit together. We have more proportional in here than what the US women do. This has more variance. Could have talked about that over here on the spread as well, that the US women have more variance. Okay. The frequency scale could be adjusted to be equivalent. So we could see, whoops, I didn't mean to mark out could. So we could better compare the heights of the bins. Better compare the heights of the, you can call them columns, you can call them bars, whatever you want to. I'm going to call them bins, B-I-N-S, so we don't think I'm calling it a bar graph. But if these were the same, if these numbers match this numbers and vice versa, I mean, the highest column here is 15, where this highest column is 18 or so. So it would go way up here on the, if we took this one and laid it on top, that'd be much taller. So we need to talk about the frequency needs to be the same instead of going both by 5. Both of them need to be by 5s or both by 2s, whatever it might be, to be able to more accurately compare the two. All right.